Sure. What we've done is we brought over the Ensoniq sound chip from a Mirage keyboard and put it as part of the Apple II-GS. So that allows us to do both digitizing and synthesizing of songs and music. What I'll play is a sample off of a compact disc player.
Okay, so this was a digitized signal off a compact disc stored in memory?
That's correct.
Okay.
You can either store it in memory or save it onto a floppy disk.
What's the capacity? How much can you store? How much can you digitize?
You can digitize up to as much memory you have into the system. The Apple II-GS, you can have up to 8 megabytes of memory. So you can have a waveform of that length.
Now this particular sequence is how long, this segment?
This is about 600K in length.
And that's how many seconds?
About 28 seconds.
Okay.
And this demonstration you're showing us, this isn't a particular software product. This is just a demonstration program to show us how you can digitize sound. So
that's
people
correct.
aren't going to go out and buy this particular thing, whatever it is. Okay, what about the synthesizing end?
In synthesizing, you're probably familiar with a program called Music Construction Set that was brought out on the original Apple II. The programmer, Will Harvey, has had quite a bit of fun with the new machine and the Ensoniq sound chip.
Now, the idea of the music construction set is to, what, you basically can make up the music yourself on the machine, then play it back. It's digitized and then play it back again?
Actually, you compose music on a music sheet, as you see on the screen here. Let me load in a sample.
So you're pulling up a file of a song that's already been written?
That's correct. So you can see the notes on the screen.
And there's the score.
We'll say
and you
play.
can play it. Okay. And all those icons on the right would be your usual composition maneuvers and controls you would have if you wanted to write that music. And again, the big difference between what you can do now and what you could do with Music Instruction Set on the Apple IIe is what?
The original version on the Apple II allows you to play 4 voices. This allows you to play 15 voices all at the same time.
How does that sound processing compare with the Atari and the Amiga?
Well, we believe we have a very powerful horse-powered engine in here that allows you to play back that many voices all at the same time.
Okay, Curtis, thank you. Now we've seen what the Apple II-GS can do. We've seen lots of computers that can play music. Now we're going to take a look at a computer that can listen to music. Wendy Woods has that report from Stanford.
Researchers at Stanford's Center for Computer Research in Music and Acoustics are trying to imitate the human ear with a computer program. Specifically, the computer must not only hear the music, but distinguish between several notes or harmonics played at once. In this experiment, a piano solo was recorded through a microphone onto tape. Researchers wanted to find out if the computer could play back the performance with the identical pitch, rhythm, and harmonics. The experiment required artificial intelligence, so the powerful programming language called Lisp was employed.
The research entails trying to find algorithms which, say, imitate how our ear understands musical signals. So using Lisp, we have a good workbench or tool bench for this kind of experimentation.
The tools also included a mini computer, signal processor, and a synthesizer. This was the result. The piano is heard first, followed by the computer's reproduction accompanying the piano music. Another part of the software will write a score for the music and print it out. The entire process of analyzing one 30-second piece of music takes an entire afternoon for Stanford's Foonly mini computer. But as faster, more powerful microprocessors reach the market, the process could happen live time. For the Computer Chronicles, I'm Wendy Woods.
Joining us now in the studio is David Schwartz, president of Compusonics of Palo Alto, California. And back with us is George Morrow, our frequent commentator and sometime host here.
Stuart, I just wanted to mention we finally got all the computers on. We got an IBM PC now.
But there's something else there.
I think it's important to point out here, this is a product that David has called Compusonics, and it's a recorder, as I understand it. And I'll have David explain a lot more about that. These two pieces of equipment don't normally go with it.
Right.
And it's part of the editing system he's also going to show us. So, David, could you describe the Compusonics?
Well, the Compusonics DSP-1000 is the world's first optical disc audio recorder. So unlike tape recorders or any other type of recording device you've ever seen before, this machine records on rotating computer memories, discs, This is an optical disc used in the computer industry for recording, say, insurance company data or records or maps or whatever, oil company records. In this case, we've recorded music. You can actually see it recorded on the disc here.
It's a little bit small for me to see the music, but I think that's important to point out that the compact discs that people are used to nowadays, the little shiny silver things, they're what's called a read-only memory, and that is you can't write on those things, you can't record onto them. And so this gives you basically the quality of a CD audio, but you have the ability to record on it also. Is that correct?
That's the important thing. It's recordable, and not just recordable. Recordable in a permanent way. I'm not sure if you've ever had a tape wear out on you, or jam, or get destroyed, or something like that, or just plain fall apart.
Even more than that, I mean, you can massage and manipulate this music on the disc once you've recorded it, can't you?
Of course. Well, it's data.
Yeah, show us that.
Data.
Yeah.
This is a program that we call the DSP-1000 PC program, which is a software disk for the IBM PC. It will also be available for the Apple Macintosh in a very similar form, of course in black and white. And it allows you to list the tunes on a disk, database them, if you will, play them from the function keys on the IBM PC keyboard, or I think even more importantly, process the data. And that is a process like EQ, boosting the mid-range or reducing the level of the bass, for example. Or let's say that you have noise on your
Can you show us how you
Well, this key here, process. Of course, the process key, we move to a noise removal process screen, which automatically searches the data for impulse noise.
So the computer found that blip.
Exactly. This right here is probably a scratch on the record that was recorded, of course, in the data on the disk. Then the computer proposes to replace the scratch with the average signal from both sides of the scratch. And of course, you listen to that, and if you agree with the computer software, you push the F10 key and remove it.
And you edit that piece of music. Now, you recorded, I think, on this compact disc a piece of music from earlier in the show, didn't you?
Yes, I did. I was up in your control room
recording. Can you prove that you did that for us, and this really works?
Here we go.
Okay, and that's a piece of music we heard earlier in the show.
That was a Midi synthesized piece, synthesized in a computer and then fed out analog and right into the input jacks on this machine.
George, I want to ask you, now I know you're a collector of 78 records with lots of scratches on them.
That's right.
What do you see you could do with something like this?
First of all, Stuart, I think I could probably take the worst of the noise out of my records. I could restore a lot of these historic recordings to something close to what they were in the very beginning. But then what this makes possible is something much more than that. If I did some analysis about the early acoustic recordings and then could take out the effects of those horns, then perhaps we could hear some of those early recordings as they might have actually sounded in the studios. It's one of the most exciting things that you can imagine.
David, what is the market for this machine, other than weird guys like George here?
Well, it's really for people at the top end of the audio market, audiophiles, who are extremely serious about their music and can afford
just like me,
a $7,000 recording device that is the state of the art in recording.
Except I can't afford it.
And what is the price of the medium itself?
Right now, these are $100 each, and they record about 80 minutes of stereo on one side, or a slightly more expensive disc recording 80 minutes on each side.
David, one last question, just about out of time. Do you see this thing ever coming down in price where it really does become a consumer item?
I see it coming down an order of magnitude, that is to $700, providing that the concept becomes a little more popular now that we're just introducing it.
David, fascinating. George, thank you. We're out of time. Thank you for joining us. We'll be back in just a minute with this week's Computer News.
Sitting in for Stuart Chaffee. In the random access file this week, look out for Commodore's latest promotion of its Amiga computer. The price of an Amiga 1000 system with a color monitor and 256K of memory falls between $500 and $1,490. Also, if you buy an Amiga on Commodore credit this fall, you won't have to make your first payment until February 1987. Lotus announced plans to combine analysis software with financial information on compact discs, making it the first major software company to enter this emerging market. The system, called OneSource, comes with 8 databases containing 20 years of stock price information. Updated discs will be prepared weekly. Lotus expects to sell the service to banks, investment firms, and large corporations. Intel Corporation is expected to announce an agreement with IBM that will push it into the fast-growing business of making semi-customized computer chips. IBM is the world's largest maker of chips, all for its own use, and is well known for its sophisticated technology. Analysts expect this agreement to allow Intel to use some IBM technology for building semi-customized chips. This could be the first time IBM technology would be used to make chips for others. And as if it weren't enough companies making IBM lookalikes, now you can take a course to learn how to make your own clone at home. In California, San Jose State University will offer a 4-hour class that teaches students how to put together an IBM PC XT compatible system for less than $800. And in Florida this month, the National Association of Accountants will offer a similar class, which includes all the materials necessary to assemble a PC in about 3 hours. More classes are expected to pop up. Time for a look at software. Here's Paul Schindler with this week's review.
You know, it's true what they say, the world is a carousel of color. If you're among the thousands of people switching to an EGA color graphics adapter each month, you should already know that the exciting new graphics standard can display 16 colors out of a total of 64 available. The question then arises, how do you get at the other 48 colors that don't pop up each time you boot your system? Well, you can do it with tricky programming, or you can change colors with Color Magic, a nifty utility program produced by the people who brought you the Volkswriter word processing package. Now, Color Magic gives you 16 canned color spectrums. EGA people insist on calling them palettes. One of the available palettes is an especially kinky one called Colors Not Found in Nature. Now, the whole idea may sound a trifle pretentious, but the right combination of colors can really improve the comfort of staring at a CRT for long periods. Besides, designer screens are fun, and former monochrome users will delight in mixing and matching colors. Color Magic, $40 from Lifetree Software of Monterey, California. For the Computer Chronicles, I'm Paul Schindler.
In the legislative update file, the IRS continues its automation program. Businesses from anywhere in the country and individuals from 7 sample cities will be able to file 1986 income tax returns electronically. For the first time, electronic filers will be able to get an electronic refund if they include a number on their form identifying their bank. The IRS will instruct the Treasury Department to use electronic transfers to credit the taxpayer's bank account. Wondering how to send your latest drawing to a friend? Telegraphics of Cambridge, Massachusetts announced a $99 program that allows you to transmit graphic images via electronic mail. The program, called Television, uses compression and encoding techniques to reduce the amount of data necessary to define an image, then sends it through commercial email services. The recipient needs to use another copy of Television to decode the image. The program is available for IBM PCs and compatibles. Finally, are you afraid of computers? If so, you're not alone. 1/3 of all workers in the United States reportedly experience some form of uneasiness when they work at a computer, and about 1 in 20 suffer severe reactions. Wonder if you could call this an allergic reaction. Well, that's it for this week's Computer Chronicles.
The Computer Chronicles is made possible by Leading Edge, makers of IBM-compatible computer systems, including Lotus Lookalike Spreadsheet, word processing with spelling correction, communication software, and Hayes-compatible 1200 baud modem. Leading Edge with over 1,000 service centers nationwide. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover developments in computer technology worldwide.